Hello everyone, my name is Hrithik Manikandan. I'm a Year 11 student from the UAE currently enrolled in the Clever Junior Data Scientist program. Today I'm excited to share a special project I worked on, the breast cancer prediction using machine learning. This project was built with guidance from my mentor, Mr. Abhishek Das, and it's a self-initiated project beyond the standard course syllabus. A little bit about myself. I'm passionate about finance, AI, and creating data-driven solutions that can make a real impact. Currently, I'm learning AWS, Python SQL, and Power BI, and also the data science, which help me understand both the technical and analytical sides of data science. I'm particularly interested in applying these skills to innovative fintech projects and any real-world problems that can benefit from machine learning. And also, I'm a published author for a book called The Fire We Kept. So this project is a machine learning based prediction system that determines whether a tumor is benign or malignant based on medical diagnostic data. I used the breast cancer Wisconsin diagnostic data set, which includes features like cell size, texture, smoothness, and perimeter, and more. The main goal of the project is early detection to help doctors make faster and more accurate decisions, potentially improving patient outcomes. So the utility of this project is significant in a medical context. It allows doctors to make data-backed decisions more quickly, reduces the risk of human error in diagnosis, and provides a scalable approach that could be adapted to other medical data sets in the future. Ultimately, it demonstrates how machine learning can support healthcare professionals and enhance the efficiency of diagnostic processes. So what makes this project unique? It makes it unique is the comparison of three different machine learning models, random forest, logical regression, and light GBM. To find the best performing approach, I've evaluated each model based on accuracy and F1 score, allowing for a clear comparison of performance. Additionally, I built a Tkinter-based UI, making the tool accessible to users without programming knowledge. This means doctors or medical staff can input patient data and get predictions instantly without needing to run code. Before training the models, I performed exploratory data analysis (EDA) to understand the dataset thoroughly. I checked the dataset overview, including the first few rows, summary, statistics, and data types. Visualizations included the diagnostic distribution, pairwise relationships between features, and a correlation heat map like this one to identify which features were most strongly associated with malignant tumors. EDA was crucial in ensuring that the data was clean, well understood, and ready for model training. For model implementation, I first split the dataset into training and testing sets. Using an 80-20 ratio, I applied the standard scalar to normalize the feature, which helps the models perform more accurately. I trained the three models, random forest, logistical regression, and IGBM, and evaluated their performance using accuracy and F1 score. After comparing the results, I selected the model that provided the best balance between precision and recall for predicting malignant tumors. Now I'd like to show you the Tkinter GUI in action, which brings the model to life and allows anyone to use it easily. This is the user interface I designed using Tkinter. Users can input measurements such as mean radius, mean texture, mean perimeter, mean area, and mean smoothness. After entering the data, clicking the predict button runs the trained light GBM model in the background. The system then displays whether the tumor is predicted to be benign or malignant. Let me show you. Let me enter the values for each of them. And then when I press the predict, it says malignant cancer. So this GUI makes the model accessible to medical professionals and non-technical users, providing immediate and actionable insights. So through this project, I developed and strengthened several key skills. Data processing and cleaning, which ensured that the dataset was reliable for training. Model evaluation and comparison, learning how to assess which model performs best in a real-world context. Visualization techniques using Seaborn and Matplotlib to explore patterns and communicate insights effectively. GUI designed for ML applications, allowing the model to be used by non-technical users. So Clever's hands-on learning approach helped me connect the theoretical concepts to real-world applications. The explanations were very clear, and the environment was supportive, which made it easier to take on challenging auto-service projects like this one. I'm also grateful to my mentor, Mr. Abhishek Das, for this patient guidance throughout this project. He helped me translate theory into code, provided constructive feedback, and encouraged me to experiment and learn independently, which made this project successful and enjoyable. Thank you so much for watching my presentation. I hope this project demonstrates how machine learning can be applied to real-world healthcare challenges and inspires others to explore data science beyond the classroom.